Assalamualaikum and very good morning to Doctor. My name is NURUZAILA, which my teammate is NURUL Ain NATASYA, NURUL AFIAH, QURAIRATU NURUL Ain, NABILA and me. We are from Group 4. And today we want to present you about this one journal titled is Development of a Simplified Radiation-Induced Emulsion Graph Polymerization Method and its Application to the Fabrication of a Heavy Metal Adsorbent. This journal was by Masaki Omichi, Yuji Oki, Noriaki Seko and Yasunari Mekawa. This journal is from 20th August 2019. Okay, before we go into deeper for our journal, I want to present you about the introduction. The introduction is radiation-induced graph polymerization is used for biomedical and environmental materials. It has a two method, which is the first one is simultaneous and the other one is pre-irradiation. The simultaneous method is a simpler but generates ungrafted homopolymers, while the pre-irradiation method is more complex but produces less ungrafted homopolymer. The pre-irradiation method is more practical and can be improved by emulsion graph polymerization, which requires a lower radiation dose and less monomer concentration. However, dissolved oxygen in the monomer solution can inhibit graph polymerization. The paper introduced a simplified radiation-induced emulsion graph polymerization method that effectively removes dissolved oxygen from the monomer solution and enhance the technology's value. Okay, then the second one is we go to the material in this journal. The first one is polyethylene coated polypropylene, which is PE or PP, non-woven fabric trunk polymer in SREG. The second one is glycidyl methacrylate GMA. The third one is polyoxyethylene sorbitol malurate, which is called as a twin 20. And the fourth one is cobalt chloride. And the last but not least is total irradiation dose range from 5 to 20 kilogram at a rate of 10 kilogram per hour.
Okay, next is the procedure. First, use SREG method, which is simplified radiation-induced emulsion graph polymerization method. Okay, so PE/PP non-woven fabric was cut into pieces and packed into a gas barrier bag. It's then sealed under vacuum and irradiated with gamma rays at -79 degrees using dry ice. And then it is stored in -80 degree freezer until used. Then 5% glycidyl methacrylate or GMA was mixed with 0.5% twin 20 in water and stirred for 5 minutes. The emulsion is degassed with nitrogen gas to remove dissolved oxygen. 120 ml of deaerated GMA emulsion was poured into a sealed glass jar with irradiated PE/PP fabric. The lid was closed with a 400-gram weight and the gas in a vacuum desiccator for 15 minutes. Then it's incubated in a 40-degree water bath for 1 to 3 hours and the fabric was washed with water and methanol. The next step is the introduction of immunodiacetic groups onto PEPPG CMA fabrics. So, the fabric was soaked in 0.5 disodium immunodiacetate or IDA solution in a 1:1 ethanol water mixture at 70 degrees for 24 hours. And then, the fabric was washed with water and methanol, and the FTIR ATR spectroscopy was used to confirm immunodiacetic groups. And the third step is the heavy metal adsorption test. So the grafted fabric was cut into a 1 centimeter diameter disc, and the fabric disc was soaked in a 10 ml of 50 ppm cobalt chloride or COCl2 solution at pH 5.8 and soaked at 25 degrees for 6 hours. The solution was observed at various times and each sample was diluted 30-fold with 0.1 molar nitric acid solution and analyzed using ICP-OES.
Okay, the third one is the result and the finding in this journal, which is the first one is GMA was chosen as a grafting agent as it could be easily converted to structures having a various function. The second one is the main role of the wick was to control the pressure in the sealed glass jar, and the third one if the atmospheric pressure in the jar suddenly decrease below the vapor pressure of the solution, it will be occur a bumping. Bumping will be occur. And the next one is evaporation of the solvent was negligible during the vacuum degassing because evaporation of the solvent caused a drop in the temperature. It will be caused by the vapor pressure to decrease. And the fifth one is even at a low dose as a 5 kg, the graft reaction proceed and the degree of the grafting obtained had a very high reproducibility. And last but not least is the method produced the initial velocity of grafting that was ideally proportional to the dose at the dose of a radiation.
So, for the conclusion of this journal conclude that the SREG method was developed using a commercially available sealed gas jar instead of expensive experimental equipment. And this method, which is SREG method, is very simple and provide highly reproducible data that can be used for high throughput screening of the grafting reaction compared to conventional graft polymerization methods. And they concludes that several samples can be produced using this method and the reaction scale can be adjusted as necessary. That's all from us. Thank you.